Welcome back, everybody. Hope everyone had a good break, got some ice cream and coffee. Up next, we're going to have building complex apps on Parse.
Hey, everybody. Welcome to F8. I'm Hector Ramos, and I lead the developer advocacy team at Parse. And I've been using Parse for about 3 years now. And
Hi, everybody. My name is Eric Nakagawa. I am a new developer advocate at Parse. I found out that I've been using it since it launched in beta, so I've had a lot of experience. Excited to talk to you guys today.
Yeah, so we both work on the developer advocacy team. We work to help you build better apps. It is our job to get all your feedback, make sure everything works correctly, and that we're working on the right features for your apps. So hopefully today, you'll learn a few new tricks to make your apps better. So this talk is going to assume that you've used Parse for a little bit. You already know how to save objects, how to query objects, how to send push notifications. So we'll just go through some features and see how they can all come together to make your app better. And at the end of this session, we will have some time for a Q&A if you have any questions. So the first thing I want to talk about is push notifications. This is something that many, many Parse apps use. And I just want to show you some examples of how you can improve your usage of push notifications in your app. So one very common question I get a lot is, how can I get a list of all the push notifications that I have sent to one device? Maybe you're working on some sort of communication or messaging app, and you want to make sure that all the messages that you sent to one user can be displayed at any time. Well, something you have to consider is that push notifications are not persistent. They are basically a delivery mechanism. They let your device know that there's new data available. They will not always be received by the device for any kind of reason. Maybe the device was offline. Maybe the user turned off notifications because you've been sending too many of them. So if you want to make sure that you can always get a list of all the notifications you have sent to one device, you have to make sure that this content is stored in a persistent manner. So if you've been using Parse for a while, you know that this means that you have to use Parse objects to store this data. So what I want to suggest is, instead of thinking about how do I send a push to all these devices, and then how can I ensure that I always show a list of all this information, just make sure that you start by actually saving this data to Parse in a persistent manner. So what this means for our example app is that we're going to save these notifications as a Parse object. We can call it message. And this Parse object is very simple. It only has the bare minimum of information that we need to recreate a notification later on. In our case, we have the content of the push notification. We have a pointer to the user who is going to receive the notification, as well as who sent it. This comes in useful later because obviously you need to know who is going to receive this message. But also, you might want to add the name of the sender to the push message itself. So before we get to sending push notifications, let me just reiterate why saving this data to the database is so important. It means that at any point when your app is launched, the device can just go and query that database and get an up-to-date list of all these notifications. And it doesn't matter if it got the notification or not. Now, since we're using Parse objects to store this data, we can take advantage of Cloud Code. Cloud Code let us define triggers that run before an object is saved or after. In our example, we can use before save triggers to ensure that the messages that are created are valid, which might mean they have a recipient. They're not being sent to no one. And maybe you can validate that whoever is sending this message actually has a pre-existing friend relationship with the other user to avoid spam. But we're not going to cover before save here. We're going to focus on the after save, which is going to help us actually trigger a push notification to be sent after the object is saved. Again, I want you to think about this change in paradigm. We're not sending push notifications by itself anymore. We are storing the data, making sure that it is persisted to the database first, and then we just let Cloud Code take care of delivering the push for you. This means that you can turn off client-side push notifications in your app, which will result in a safer and more secure app. So how does that after save trigger look like? Well, this is an example of Cloud Code. This is an after save trigger on the message class. And as you can see, it uses JavaScript. And you're defining a function that will be executed when the object is saved, after the object is saved. Here, we are making sure that this is the first time that the object is being saved. This is not an update, because you don't want to send a push again if the user goes back to edit the message. So we make sure that the object is new. Then we get the content of the message, the recipient, and who sent it. And we call this function that we will get to in a few moments. And that function will take care of sending the push for you. And to go into the actual function itself, Eric?
OK, so if you're building a messaging app and you want to send pushes to a particular user, you first have to understand how pushes work on parse. On parse, every call to the push function requires installations. Installation happens every time an app gets installed by a user on a mobile device. You may have a set of users or a number of users, but much more installations. What we suggest is when you're building your application and a user signs on, meaning your app has connected to parse, we suggest that you add or update a pointer to that user on that particular installation for that device. What that allows you to do is, in the case of your messaging trigger, it allows you to change the way that you actually query which devices should get pushed to. In this example, the code here shows that instead of querying a particular the messaging class, we instead query the installation collection and find all the installations that match that particular user, and then supply that to our push function. This changes the way that you would push from being kind of run once at a time to pushing to all people that should receive this particular message. Let's go back to Hector to.
Yeah, so we just saw how we can send push notifications to a specific user. But let's say that in our app, let's say that we want to send the same message to a bigger group of people. Maybe you just created a new feature, and you're launching it to just your users in San Francisco. So let's take that example and think how we can go about that. A naive way of doing this would be to basically query for all users that have a city equal to San Francisco, and then for each of those users, call that function that we just created. That's going to work, but in a city like San Francisco, you might have hundreds of thousands of users. It's going to take a long time to go through each user and send them the same message. So what we do here is, since pushes are sent to the results of running a query, we can just build a query that matches all the installations that have a user that matches the results of running a query over users, where city equals San Francisco. And that's going to work. It's going to basically run once and target everybody that matches that criteria. And it's going to run pretty quickly. But it's quite easy to end up with some complicated queries here when all you want to do is easily send push notifications to big groups of people. What I want to suggest is whenever you're thinking about which types of push notifications you're going to send to your users, how you're going to target them, just make sure that whatever targeting criteria you're using is actually copied to the installation class. That way, instead of building some query with an inner query over the user class and then some other class if you want to do something more advanced, you just have to build one simple query over installations. What this means is that we can probably use something like an after save on the user class, which whenever the user updates their city, we go to the installation and we update that as well. And now, once we have replicated that data on the installation, it means that we can go from the more complex query that I just mentioned, where we query for installations that match users in San Francisco, to something much more simpler to manage. Now we just query for installations where city equals San Francisco. This is easier to follow, easier to handle, and it's also going to make it easier for non-technical folks to use your push console on the web, because the push console has a more limited query language, and that way they can just go in and choose the city and just go out. It just goes out. So, Eric, do you want to talk about object security?
Sure. So, say you've launched your application, or you're building it, and you're getting ready to launch it, and you find out that somebody's able to find your app ID, your parse app ID, and your key. It's a little worrying, but there's certain things you can do to prevent some security concerns. Why would somebody do that? Well, it's pretty common. If a user is given a chance to snoop around in your data, some of them might. If you've built like a game, why not hack your way to the top of a high score list? Very common. If you built a social networking app, people may want to peek at other users' data. If you've built a messaging or a dating application, somebody may try to find pictures that people don't expect them to be able to see. The most common way people can access your keys is by taking a look at your JavaScript code, where it will have your JavaScript key and your parse ID. Other ways they could do it is by decompiling your application. Decompiling an Android app that hasn't been encrypted can also share or leak this information. So quickly, just to talk about what you should do, some suggestions would be only providing the minimum permissions needed for each of the classes in your application. You can modify what the public can see by editing using the class level permissions editor. And if you want to use more complex or granular types of security permissions, you can use the ACLs list. And this allows you to be very granular as to who can see what, who can edit what. A common example that I see sometimes is that people will load up their user object with some sensitive data that they might not want other people to see. Email addresses, phone numbers, your birth date. If you're using your user object, I'd highly caution not doing that, and instead moving that information out of the user object and into a detailed user object, or whatever class you want to name it. By moving the data out, you can then provide more specific control as to who can see that detailed object. In this case, I would actually set the detail object's ACLs to only allow viewing and editing by the particular user who has set it. In this example, I also suggest creating a pointer to this detail object to make it easy to quickly find this information. Another example that this sort of model could be used for would be something like providing extended permissions to your users, so that you can have your list of user data here, and separately have your permissions within your application separate and only viewable by your cloud code via master key or by the particular user. So let's head back to Hector.
Yeah, so Cloud code is something that many Parse users use in their app. And I just want to go through some tips that hopefully will help you write better cloud code. And I want to start with a very basic mistake that people new to cloud code make. And it's just basically failing to understand that operations may be asynchronous. I'm going to show you an example of what I mean by this. Let's say that we want to write a function that goes and fetches a user, gets their name, and then just prints out their name. So you might do something like this. Query for the user, and then print out the name. Well, this is actually not going to work as you would expect. If you run this code, you will see that my name is unknown. It did not execute in the order that you might think it does. And the reason for this is that when you're using network operations, they are asynchronous. They don't block the execution of your code. So in this case, when we are printing out the value of the name, that line is actually running before the callback is running. So if we want to make sure that when we print out the value of this object, if we want to make sure that it's updated and we have the actual value, we need to move that print statement into the callback of that query operation. That's going to make sure that we actually have the data that we're printing out when we need it. And you can do this for any operation that needs to fetch an object and work on it further on. And with that, I want to move on to something very, very important when you're working on cloud code. If you are not using promises, I highly recommend that you go to our JavaScript guide and read about promises. Promises, they are a pattern that helps you encapsulate the result of running some operation. And once that operation is done, you will get a result, be that a list of objects that match that query, maybe a successful response saying that, yes, this user signed up. Or you may get an error, and that object will tell you why it failed. The important thing about promises is that they can be chained one after the other. They help you write better serial and better parallelized code. And to show you an example of why promises are so important to use in cloud code, let's just look at some code that does not use promises. So before I get into that, let's think about an app that I'm working on. And it's a game. And this game has rounds. And we have 2 players. And I'm tracking the score for each player on its own class called game score. And I want to make sure that at the end of each round, I go and fetch player A's score. I update it and save it. And then I go fetch player B's game score, update it, and save it. So if I'm not using promises, it might look something like this. I have one first query for the first score. I update it. Then I go get the second score object. I update it, and I save it. And this is a pretty simple list of operations. If I need to do even more complex operations, I might end up with a very, very long chain of callbacks. And this is only handling the one case where every single operation is successful. This code is not complete yet. This code is not handling any error that might occur in the execution of all these operations. So if I go and add in those error handlers, I end up with code that's really hard to follow, it's really hard to maintain, and it's hard to collaborate on code like this. If you want to add some branch, some new logic, it's hard to tell which callback I need to edit. And this leads to another common error that I see people run into. If they use this on a cloud function and they don't handle every possible error, you might see in your logs a message that says success/error was not called. And this happens because some operation failed, but you forgot to add the error handler to catch that error. So if we actually use promises to do the exact same operation we did here, the code looks so much simpler. We have 4 simple steps, one after the other. It's very easy to see where you are in this chain of operations. And even better, you have just one error handler that's going to work for any possible failure in this chain of execution. That is because when you chain promises, errors will propagate until they reach the first error handler. So here, I can make sure that whether it was the first query that failed or the second save that failed, I'm going to catch that error and clean out my function completely. Nothing's going to stay hanging. So you can see how promises makes your code much more readable. But there's another advantage to using promises, and that is it helps you parallelize operations easily. If you look at this code, we really don't have to wait for the first query to finish before we go and get player B's score and update it. We can probably just query for player A and player B's scores at once, update both objects, and save them at the same time. So let's go to my next recommendation. Avoid unnecessary serial promises. If the next step in the chain does not need to wait for the previous step, just see if you can probably run those operations in parallel. So in our example, it would look like this. We would have one promise called parse.promise.when, which takes 2 queries. And that promise, when you use .when, what that does is every single promise that you pass to that, we will wait for all of those operations to finish before we go to the next step. So in this code, we run the 2 queries, we update each object individually, and then we use parse.object.saveAll to save both objects at the same time. We just went from 4 sequential operations to 2 parallel operations. This is going to cut your execution time in half at least. This does not only mean that your functions will complete within the time limits, it also means that your users will have a much better experience. They don't have to wait around for your code to execute.
Cool. All right, so another common question is, how do you develop better? If you're building or working on an application on Parse with multiple people, it's pretty common to try to figure out how do you not step on each other's toes. A very kind of common way to do this is split up your main.js file. By doing this, it allows you to set up and break out the functionality so that if you're dealing with stuff like users, you put that into a user file. If you're dealing with updates or different types of objects, separate that into their own files. And in the main.js, refer back to them by requiring them back in. One thing that I've learned is as you progress building applications on Parse, you start to learn certain things. And this is one of those things. As your app gets bigger and bigger, you don't want to have a giant file. Some of the best things about splitting up your project like this is it allows you to develop with multiple people, and you're probably storing your project in source control, so it'll allow you to better merge without having to update just one single file. Also, when you run into errors or you have some issues, you can localize or figure out that a bug may be occurring in one particular piece versus your entire main.js. So that being said, we covered a bunch of cloud code tips, but one thing I'd like to talk about is how do you use your data outside of Parse? One question that we get for people that have a lot of data within Parse is, how do I get this data off? There's a couple methods that I'll share with you, and some new things that we just released that Makes it really interesting for what you can do. The most common method for getting data out of parse, I'm sure everybody that's tried to export data has manually done it on the parse dashboard. By doing this, you can get a copy of all your data. It'll be archived and alerted when we've been able to create that and have it ready for you to download. There's also other methods. If you've used the data browser, we've added a recent feature where any filters that you apply to your data, say you want to get a range of data or sales information from this date to this date, applying that filter now allows you to export any of that data that you have. So any filters now apply to any exports that you do from this page. If you want to do slightly more advanced things with your data, you can use the REST API. By using the REST API, you can supply queries. In this case, I'm trying to get all users after a certain date. And I could use this on my own server somewhere. A common thing if you're doing and using the REST API is to keep track of when you actually export your data. This is a little bit of code I'd like to share with you just to keep track of when you ran your last export. If you have a script running on a server periodically, it would be good to know when was that script last executed. Moving on, you can also push data from parse to either your own API endpoint on another server or to another service somewhere that maybe that you might be consuming at a different point in your app. It's pretty straightforward within a Cloud Code function, after save, before save, anything that makes sense for your application. Just create an HTTP request and post your data. Those are basic methods for getting data out of parse. But there's something brand new that we actually just announced called the Cloud Code Webhooks. And the thing that is most exciting for me is using Cloud Code Webhooks allows you to move data to another server, and also lets you use, if you're using your own server, lets you choose whatever language you would like. It will also allow you to process data beyond the current limits. There's certain time limits for execution of function calls and jobs. And with Cloud Code Webhooks, if you have been struggling trying to get, say, some data analyzed before the 3-second time limit, using a Cloud Code Webhook now allows you to take even more time to process that data. Right now, Cloud Code Webhooks support functions before and after saves, before and after deletes. In the case of a before save, say you've created a new object, and say it's a data point that you would like to run some analysis on. You can use a before save, have the data come into parse, then send it to your server, and it will wait until it gets a response back before it completes that before save. This allows you to do a lot of different things that before this existed might not be possible. The way that you use webhooks is pretty easily. You just send back a JSON object from your server, and it could be as simple as a success true, error true if there's an error, or you can actually modify data. In this example here, I have a list of information from, say, a user object, say a test object, and I could change the data on my server, send it back to parse, and parse will then update that record for that particular object. In terms of errors, you're able to also send back more detailed information if something happens on your external server that you would like to track or track down in your error log. Cool.
Yeah, so to recap what we covered today, don't treat your push notifications as if they were persistent. Make sure to store your data in parse objects and use that to drive the delivery of push notifications. Whenever you're going to be sending push notifications, make sure that any targeting criteria exists on the installation itself.
Also, if you've launched your app or you're in development of an application, please make sure you take a look at your permissions, it's very easy to peek at your objects if your keys get released. Using class-level permission editor or using more complex ACLs allows you to avoid a lot of potential security issues.
If you're using any asynchronous frameworks, such as basically all of our SDKs, don't forget that those callbacks will execute later when the data is available. Make sure that your functions are called within the callbacks when the information is actually there. Learn about promises if you haven't used them yet. They're really, really important, and they will just make your code so much better. And
cool. Yeah, and one more thing is if you want to move your data off of Parse to do analysis, there's multiple methods for doing it. But the most interesting thing is the Cloud Code webhooks, which allows you to expand the amount of time that you might need to analyze data and still work within the Parse system. It's your data, and here's a chance to even do more interesting things.
Yeah, and look into the new Cloud Code webhooks. Our current Cloud Code environment uses JavaScript, but with the new webhooks, you can use any language you want and run any modules that you wish to. And so after this talk, we will be, Tom and Charity will be talking about, they will be going deeper into the technical aspects of the database. So be sure to come back here at 3:30 for that talk. But if you have any questions, we have about 30 minutes to go through some questions. And there will be people in the audience with microphones to help you out. So the gentleman over here.
Okay.
Yeah.
Hi.
Hi.
So I haven't seen the webhook stuff, but so what I'd like to know is, can I use it such that I can use it for doing durability testing? In other words, you guys are my first store, and then I use it, the webhook after save, to push to my store, and then commit back to the client. In other words, I want to do a full dual commit durability guarantee. Is that part of your design model?
Sure. So I don't think that's specific to the new functionality that we released. With any after save trigger, you can always just, as Eric showed, you can just pass that data on to any other third-party server, in which you could be saving that data on a second database. With the new webhooks, what this means is that you are removing one hop in that whole interaction. Instead of going to Cloud Code and then to your server, it can just go directly to your server to store that data. But the original data is also in Parse. It's up to you to make that copy.
Yeah. And one final note, because you can send back a success or a success or failure or error, you can actually determine within Cloud Code whether or not that secondary store was successful, like in your particular use case. So say you were to store it somewhere, you could respond back true, like success, true. I was able to make that secondary copy. So it's pretty flexible new tech that we really are excited about.
Hi, my name is Rudy. I was wondering if there are any plans to simplify the iOS local data store. I'm thinking about integrating that into the app, and it just seems cumbersome to unpin and pin things. Any thoughts on that would be appreciated.
Yeah, so I would be curious to hear more about any challenges that you might have faced, and we can probably talk about it after you talk. We're always open to feedback whenever we launch features like this, and we basically use that to drive what we work on next. So yeah, let's talk later.
Hi, I have two questions. Number one, after a push notification has been sent, if the user has not engaged, is it possible to recall that notification?
Is it possible to send that notification again?
No,
To cancel
recall.
it.
Oh, to recall. Well, so it depends on how you send the push notification. If you schedule the push to go later, you can cancel the push from going out. But if you send that push right now, it's already out. It's on its way. But something that you can look into is there's an expiration parameter that you can set. It basically says, if the user did not receive this notification within 3 minutes or within a day, then don't deliver it. that might help.
The number 2 question, if I want to send multiple notifications from different parts of my server code and then want to arbitrate on the client side about which is 1 or 2 notifications that I want to use or to show the user, where is the best place to put that arbitration logic, and is it easy to do that?
So it really depends on the platform. So on iOS, I don't believe there's that many APIs that can help you aggregate notifications that have already been sent out. But on Android, recently they added some new features that let you aggregate those notifications. And the way you do that is by, when you send a push to Android, there's a broadcast receiver that gets executed. And you can just customize, implement your own version, and aggregate those on the client.
Hi.
Hi.
Our use case, we let users use a mobile app to manage information about products and that type of thing. What our users are asking us to do now is build some WordPress plugins, Shopify plugins, and that type of thing so that they can get access to their inventory products in their own website and that type of thing. So when it comes to kind of authenticating that process, we'd like to avoid having to put in sort of any middle layer OAuth server to kind of authenticate a key for a WordPress plugin that gives them access to a specific user set of data. With the new session management stuff that you guys are bringing out and roles, is there can you see any way of kind of replicating an OAuth key type thing so that a user could have a WordPress plugin that they could stick on their own server that then kind of authenticates to just their set of records within my app without having to give my key to everybody that's using the plugins?
Yeah, I don't think we specifically support that specific scenario. But what the new APIs allow you to do is to better manage the life cycle of each session. And you can programmatically create new sessions. So I believe there should be some way for you to create some endpoint on Cloud Code that does that while only exposing some public token that it's available on WordPress and it's fine if people know it. But we can talk about it, probably go through your implementation offline. I have another question here.
Hi, my name is Arturo. I have a question about include statements on the promises that you talk about. Sometimes I have problems when I have to query an object that is included in another object. Is that possible to do in a promise, or what thing that I should do? The thing that I do at first was copy the object to the superior object, and then to the superior object, and then to the superior object, but it was a painful chain of promises there. So what do you do if you have a part? What also things I do is copy the object ID to another row, and then just use that object ID upside down, but it turned out a mess like you do. Well, what do you suggest to do for that kind of reports?
Yeah, so I guess the question is, how do you propagate data across the chain when that data was obtained earlier on and not exactly on the preceding chain or step in the chain? So there's two ways to approach that. You can either have some variable that's in the scope of the entire chain. You initialize it to null and then update it when you have the data. Or what I like to do is I just propagate that data throughout the entire chain. So normally when you use promises, let's say that you are running a query. You return the promise from that query to the next element, and you'll get the results of running that query. What you can do is, in the same way that we use parse.promise.when to run promises in parallel, you can just supply that value as another promise. Even if that doesn't mean that you need to, even if you don't need to query that from the database, you just pass the value. So you can do parse.promise.when, the next query in your chain, comma, the value you obtained earlier. And then on the next function, you have both parameters available.
Hi there. With your push notifications, what degree of reliability do you promise insofar as actually delivering push notifications that are scheduled?
Yeah, so we, depending on the platform, we use whatever service is best for that platform. So on iOS, we use APNS, which is Apple's push notification service. On Android devices, we use GCM. And both services, they don't guarantee delivery. So given that, we ourselves cannot guarantee delivery of push notifications. Push notifications are sent on a best effort basis. So you cannot really tell if it reached the device, but we'll try to make sure it gets there. So we have another question over there. One last question.
This is probably a pretty beginner question. Probably a beginner question, but I'll ask anyway.
It's OK.
So I see there is a concept called channel, right? And I have hundreds of users. Should I be creating one channel per user if I'm using it as a chat app? Or should I be creating a channel for a group of users for groups in the chat? I mean, is there sort of a best practice recommendation?
Yeah. So this really depends on your use case. You're welcome to use both. You could have one channel per user, and that makes it quite easy to send push to that user because they have one channel. But I believe that using the approach that we saw today of using an actual pointer to the user might be better because that way you can always get more information for that user. If you use channels, you just have a channel name. If you use a pointer, you can go get that user, get their name, get their friends list, and so on. So I would probably use channels more for situations when I want to broadcast a message to bigger groups of people. So thank you for coming here. We will be at the developer garage in the pavilion. So if you have any more questions, just walk up to any of us, and we'd be happy to answer your questions. So thank you.
Thanks.